This is Foundations of Math and Pre-Calculus 10, Chapter 2.2. We're going to be looking at surface area. And what's the difference between that and area? Well, area is just a 2D shape, whereas surface area applies to a 3D object. It's a small distinction. And it's important to understand that surface area pertains to the container, and volume is the amount of stuff a container will hold. For example, the surface area would be the can that holds the soup, and the volume is the amount of soup that we put in the can. And let's recall that surface area of a cylinder. We have the top and bottom circles. So if this was the bottom, they're both circles, so we need two circles. Each circle is pi r squared. The lateral surface area has a length equal to the circumference. So this part is 2 pi r. So if we cut it and then unwrap it, then the area is going to be 2 pi r times h. So if you ever forget, you just need to remember that this is the circumference, and then you just unwrap it and you get a rectangle. The total surface area is 2 pi r squared plus 2 pi r h. And I'm just using brackets to show how the formula was derived. Okay, let's see how the surface area of a right cone is derived. Now, at the bottom, we have a circle again. So this is pi r squared. And let's cut this cone and unwrap it. And it's going to look like this. This bottom part is 2 pi r. That's the circumference of this circle. And this slant is the radius for this big circle. So the area of this big circle is pi s squared. And the circumference of this full circle is 2 pi s. Okay, so this is 2 pi s. So this sector has a ratio of 2 pi r over 2 pi s. And if we simplify it, it's just r over s. So the lateral surface area is just that fraction of the full circle. So r over s times pi s squared. And we can cancel out an s from the bottom and an s from the top. So this is s squared, it just becomes s. And we get actually a simple formula, pi r s. Now, for some harder questions, we may be given r and h. And r and h. How can we determine s? Well, this is actually a right triangle, so we can use Pythagorean. So this is square root of r squared plus h squared. Okay, h in this case means the height of the cone, not the hypotenuse. So the total surface area for a cone is, using the first formula, pi r squared plus pi rs. And if we're not given s, we use pi r squared plus pi r square root r squared plus h squared. So you can use either formula, depending on the situation. So let's do some examples. Surface area, pi r 3 squared plus pi 3 times 5 rs. And it's best to not plug it into your calculator right away. We want to simplify this. 3 squared is 9. 3 times 5 is 15. Now these two are like objects. So we can add them together. There's 9 pi and there's 15 pi, so there's altogether 24 pi. Just keep in mind we're adding this time, so we're not multiplying, so we don't end up with pi squared. And now you can plug it into your calculator. So if you plug it into your calculator, you're liable to round off too early and get some rounding errors. That's why we want to do as much of the calculation as possible in our head and then use the calculator. So 24 pi. And this is approximately 75.4. And this is centimeters squared. Now we need to calculate inches squared. And we need to multiply by the conversion. So this is 1 inch over 2.54 centimeters. And that's squared. And on the calculator, it looks like this, 75.4 divided by 2.54 squared. And I'm doing a divide because multiplying by 1 is not going to change it. This is in the denominator. And we get 11.7 inches squared. And the centimeters squared cancel out. Okay, let's do one more example. Surface area equals pi 4 squared plus pi times 4 times 7. This simplifies to 16 pi plus 28 pi, and we get 44 pi. And we plug this into the calculator. 44 pi, enter, and calculate 138 inches squared. We take our 138 inches squared, and we want to convert it to centimeters. So this is 2.54 centimeters over 1 inch squared. We cancel out the inches. Plug it in on the calculator. 138 times 2.54 squared. And we get 890 centimeters squared. Okay, let's look at one more object. The surface area of a sphere. And a sphere is a 3D shape, whereas a circle is a 2D shape. And I'm not going to derive this formula because it requires you to know calculus. So if you learn enough math, you can take calculus in grade 12 and learn how to get this formula. So all we need to do is plug in values. Determine the surface area of a sphere with radius 5 feet in feet squared and meters squared. So surface area equals 4 pi, and we substitute 5 squared. So this is 4 pi times 25. 4 times 25 is 100. And you don't need your calculator for this. Pi is approximately 3.14. That means we move the decimal place twice. So that's 314 feet squared. And that should be approximately. And 314 feet squared. We multiply this by 0.3048 meters over 1 foot. And we have to square this. And on the calculator, 314 times 0.3048 squared. And we get 29.2 meters squared. And cancel out our units. And that's the correct solution. Let's look at one more example. Determine the surface area of a sphere with 2 meter radius in meters squared and yards squared. So we have surface area equals 4 pi 2 squared. This is 4 pi times 4. So we have 16 pi. And on the calculator, 16 pi. That's 50.3 meters squared. 50.3 meters squared. We're multiplying by our conversion. This is 1.0936 yards, 1 meter, and we square it. Cancel out our meters, and we're left with yards. Enter this on the calculator. 50.3 times 1.0936 squared. And we get 60.2 yards squared. And for harder questions, you will be given diameter. And when you're given the diameter, you need to divide that by 2 to calculate your radius. So be careful reading the questions. Good luck solving your problems. And that completes this lesson.